Let us take one example of a matrix A. A is equal to 1, 2, 3, 4. What is the size of this matrix? 2 rows by 2 columns. Okay, what is row 1? 1, 2 is row 1. 3, 4 is row 2. 1, 3 is column 1. 2, 4 is column 2. Now if you write rows as columns, using the same matrix, if you write rows as columns, the first row is 1, 2. I will write that as a column 1, 2. The second row is 3, 4. I will write it as a column, second column. First row I wrote as first column, second row 3, 4 I will write it as second column 3, 4. The matrix formed by writing like this is called the transpose of the existing given matrix. This is called the transpose of the given matrix. This is the transpose of the given matrix. What you are doing to arrive at transpose? You are simply replacing rows with columns, or you can say in other way, columns with rows. Or otherwise I will attempt to write columns as rows. The first column is 1, 3. I will write it as a row. First column I will write it as a first row. So 1, 3 is the column. I will write it as first row. Second column is 2, 4. I will write it as second row. This is 2, 4. Both are same. So the transpose involves writing interchanging, in other words, interchanging rows with columns or columns with rows. This is called the transpose of a matrix. Now, say suppose A is like this. Another example I will take. Simply another name you can take with A. We'll write B is 1, 2, 0, 1, 3, 4. Now if I find out B transpose, usually the transpose of a matrix is represented like this. The name with T in power position. A transpose, this is called A transpose and represented like this. A transpose is equal to, okay. Now here in this case B, I will write B transpose. What would be B transpose? The first column shall be R. First row can be written as first column. First row is 1, 2, I will write it as a first column. Second row 0, 1, I will write it as a second column. Third row 3, 4, I will write it as a third column. What was the size of B? 3 rows by 2 columns. 3 rows by 2 columns. What was the size of B transpose? 2 rows by 1, 2, 3 columns. So if you can see, if B is size of 3 by 2, B transpose is of the size 2 by 3. In general, if A is of size m by n, what would be the size of A transpose? N by m in reverse, because you are replacing, you are interchanging simply the rows and columns. Okay. Now say suppose one more example I will take. Say suppose matrix B equal to 1, 2, 1 or minus 1, 2, 0, 3, minus 1, 3, 5. This is B. Can you write what would be the B transpose? B transpose is equal to, the first row can be written as, shall be written as first column. So 1, 2, minus 1 shall be written as first column. 1, 2, minus 1. Second row is 2, 0, 3 shall be written as second column. So 2, 0, 3. Minus 1, 3, 5. Third row shall be written as third column. Minus 1, 3, 5. If you find out this, if you compare this, B and B transpose looks same. If you see here 1, 2, minus 1, 1, 2, minus 1, 2, 0, 3, 2, 0, 3, minus 1, 3, 5, minus 1, 3, 5. So this kind of a matrices where B, the matrix is equal to its transpose, such matrices are called symmetric matrices. Okay, another example I'll give you. Say suppose matrix B I will take, I will write it as C since we have used B already there. So I'll write C. I'll take 1 minus 1 minus 2, 1 0 0 0 minus 1 minus 2, 1 0 3, okay, 2 minus 3 0. This is the matrix, say suppose. Now what would be its transpose? C transpose is equal to first row, first column, or first row I'll write it as a column 0 minus 1 minus 2, then 1 0 3, then 2 minus 3 0. I have directly written here since we have already written twice or thrice. If you compare both, the first element is 0 here. Here this element is minus 1, here it is 1. Here it is minus 2, here it is 2. Here it is 1, here it is minus 1. Here it is 0, 0, 3 and minus 3, 2. Here minus 2, minus 3, 3, 0, 0. If you compare both this one, what would be minus C, or simply what would be minus 1 into C? That is equal to minus 1 into the whole matrix. I'll write the matrix 0 minus 1 minus 2, 1 0 3, 2 minus 3 0. How scalar multiplication with a matrix has to be done? It has to be multiplied, the corresponding scalar has to be multiplied with each and every element of the matrix. Now you multiply minus 1 into 0 is nothing but 0, minus 1 into minus 1 plus 1, minus 1 into minus 2 plus 2, minus 1 into 1 minus 1, minus 1 into 0 0, minus 1 into 3 minus 3, minus 1 into 2 minus 2, minus 1 into minus 3 3, minus 1 into 0 0. If you see, this is nothing but C transpose. C transpose, both looks to be same, isn't it? So this kind of a matrices where C transpose is equal to minus C are called skew-symmetric matrices. Skew-symmetric matrices. What did you observe in both symmetric matrices and skew-symmetric matrices here is, if you see in the symmetric matrix example I have erased, I'll write it here. 1 2 minus 1 2 3 4 minus 1 4 5. This is, say suppose B, and B transpose would be 1 2 minus 1 2 3 4 minus 1 4 5, where B is equal to B transpose. Okay, in this case if you see, the diagonal elements in B and the diagonal elements in B transpose both shall remain same. Correct, right? What is the diagonal elements in B? 1 3 and 5. What is the diagonal elements in B transpose? 1 3 and 5. So in symmetric matrices, both the diagonal elements shall be same. In skew-symmetric matrices, if you observe here in C, the diagonal elements across here is 0, the diagonal elements across here is 0. So in skew-symmetric matrices, always the diagonal elements shall be 0. If C has to be equal to minus C, here say suppose X is there, here minus X shall be there. X is equal to minus X. Say suppose X is there here, and since C transpose and since it is skew-symmetric, it shall be minus X here. So X shall be equal to minus X means what it will come? X plus X. If you take out here, X plus X is equal to 0. Minus X will become plus X here, so 2X is equal to 0, so X is equal to 0. So for a matrix to be skew-symmetric, all the diagonal element shall be 0. For a symmetric matrix, diagonal elements in its in the same in the original matrix and in the transposed matrix are same.